Today we solve JEE Advanced 2025 Physics toughest question. Here on that question we have to find angular velocity of the small disc. Here we show that a big ring. Inside the ring we find a disc of m mass is connected through a spring which spring constant is k. So we find spring key increase. If disc rotate from this direction, it distance cover this length, and so this length is equal to this small disc center change from this point to this point is this length is equal to this length, and this is the arc of circle, and radius is r minus r because big radius is r and small radius is r. This r total r, so this is r minus r. So s equal to r theta, we apply this formula and find spring length increase equal to x equal to r minus r into theta. So we find this, and we have to consider no slip condition. This means the ring always attached with the outer surface of inner surface of big ring, did not bounce back, there is no bounce. So for this reason, if small disc rotate phi angle, then it cover this arc, and in the inner surface it goes to this length, and this length is equal to this length, অর্থাৎ means r minus r times theta equal to this length r theta. Here at the animation we find that the arc of r minus r theta is equal to r in times phi. We already saw an animation and clear the visualize. So we finally we understand no slip condition. From this we find the value of theta as a function of phi. Now we have to calculate angular velocity, so we consider torque, angular acceleration and moment of inertia. We know that torque equal to tau is equal to alpha times I. Now total torque tau, here we find total force and times radius of the small disc. Here we find two types of force. One is weight or gravitational force of small disc, and other is spring generated force or elastic force. Elastic force is kx, and in inner direction, if we consider small disc goes from this point to this point, then elastic force is kx. X is increase or extension of spring length, and the weight is mass is m, then weight is directly vertical direction mg, and this angle is theta, so this angle is theta. So this is mg cos theta, and the other part is mg sin theta. This was same aligned with the spring force, so these two forces are added. So we find mg sin theta, and the minus here for this force is against the path of x or increase length of spring, and we also times r, we find tau. So here as theta is very small, so sin theta is equal to theta, we can consider equal to theta. So and then total moment of inertia, we find angular a small ring own inertia and a big ring inside the surface of ring this only rotate and through the surface rotate. So we find mr square plus half mr square. This is the small angular for on disk on angular momentum, and this is the inner surface. So we find total moment of inertia 3/2 mr square. Now we put all together into the equation, and through some calculation we find alpha is the angular acceleration is equal to eta is equal to this, and then alpha calculate, and we know alpha is equal to d square phi by dt square as angular displacement of small disk phi, and we after some calculation we find this result. Here we find we can consider we compare this equation with d square phi by dt square is equal to minus omega square into phi. This is a simple harmonic motion equation, second derivative equation, second order derivative equation, where omega square is the square of angular velocity. So this is equal to this full value. Then we equalize is, and then finally we find omega angular velocity, which is equal to root over 2/3 times g by r minus r plus k by m. This is the final answer of the JEE question.